So in this presentation we're looking at the trends in the physical properties of the alcohol family. This is part of the Nature's Chemistry unit in National 5 Chemistry. So at the end of this presentation you should be able to describe and explain the trends in the physical properties in alcohols as that alcohol size increases. If we go from methanol to ethanol to propanol to butanol, etc., you should be able to describe the trends in the physical properties as the size of the molecules increases. So the first task I want you to do is to get your National 5 Chemistry data booklet and complete this table for the first three alcohols. Okay, so for methanol, ethanol and propan-1-ol. Okay, so filling in the name of the alcohol and then the formula and then the melting points and boiling points which we will get from the data booklet. Okay, so pause this video now and complete this table. Okay, so to look at our results from this table and to work out what that means, we have to think what type of bonding will be in alcohols. Okay, so think back to Unit 1, Chemical Changes in Structure of National 5 Chemistry, when you looked at structure and bonding. And the type of structure and bonding we came across was covalent molecular or covalent network or ionic. Okay, and thinking about what type of bonding will be in alcohol. So looking at the melting points, boiling points, what kind of bonding and structure do you think exists in alcohols? Okay, so the low melting points and boiling points suggest we have a covalent molecular structure in alcohols. Okay, so when they melt and boil, we are separating molecules. Okay, so we are breaking these weak forces between molecules, or intermolecular forces as they are called. Okay, the weak forces that are holding different molecules together, we have to break those so we can separate the molecules. Okay, and hopefully you should be able to see from that table that as our size of alcohol increases, as we go from methanol to ethanol to propan-1-ol, okay, so we have more carbon atoms in the molecules are getting larger, that the melting points and the boiling points increase. Okay, so as the alcohol size increases, these intermolecular forces are stronger. It takes more energy for us to separate the molecules, and this means we have an increase in the melting point and the boiling point. Okay, so we can summarise the findings from looking at the melting point and boiling point information. Okay, so alcohols have, and we discussed in the previous slide, that they have covalent molecular bonding. Okay, they are covalent molecules. And we found that in the chemical changes in structure topic, when we were looking at bonding and structure, we found that the bonds inside molecules or within molecules are not affected during a change in state. When we melt or boil a covalent molecular substance, we are not breaking those bonds, those covalent bonds within the molecule. So for instance, in methanol, when methanol changes from a liquid into a gas, when we boil methanol, we are not breaking, say, the bonds that are holding the carbon atom to the hydrogen atoms, or the carbon atom to the oxygen, or the oxygen to the hydrogen. We are not breaking those covalent bonds within the molecule. What we are doing is breaking the weak forces that attract one methanol molecule to another methanol molecule. That's the forces that we are breaking. Okay. So it's these forces between molecules that are broken when we melt or boil a covalent molecular substance. Okay. And we've found from that data that as the size of the molecule increases, the melting and boiling point increases, showing that forces are stronger between larger molecules. As our alcohols get larger, as we go from methanol to ethanol to propan-1-ol, these forces between molecules get stronger, so it takes more energy to make the substance melt or boil. Okay, and also, as we're going to find out, the size of molecules can affect other physical properties of the alcohol family as well. So in this experiment, we want to look to see if there's any trends in the solubilities of the alcohols. So in these little micro test tubes here, I've just got some water, and I'm just going to add some alcohol to each test tube, and we'll look to see whether the alcohol added is soluble or not, and then we'll be able to identify is there any trend as we go from methanol to pentan-1-ol.
So I'm going to start with methanol here. If I add some methanol to this micro test tube here, give it a little shake and hold it to the camera, we can see quite clearly there that the methanol is completely soluble in water. So now I just want to repeat the process with ethanol. So if we add some ethanol to this micro test tube of water, if I give that a little shake, again you can see that the ethanol is completely soluble in water. Next in the homologous series we have propan-1-ol. So if I add some propan-1-ol to this test tube here, you might just be able to make out that it's not as miscible there. You can see a little layer there of the propan-1-ol sitting on top of the water. As I shake it, it begins to dissolve, but it's clearly not as soluble as the methanol and the ethanol. So if I now move on to the next member of the homologous series, which is butan-1-ol, and I add some butan-1-ol to the water here, we can clearly see that the solubility is reduced. You can see that the butanol is sitting on top of the water as a layer on top of the water. So the butan-1-ol is insoluble in water. And finally, we'll use pentan-1-ol. If we add some pentan-1-ol to the water, as you have probably already guessed, the pentan-1-ol is insoluble in water there. You can see it sitting on top of the water, so it is insoluble. So we can see quite clearly a trend in solubility as we go from methanol with 1 carbon atom all the way up to pentan-1-ol with 5 carbon atoms, that as our alcohol size increases, the solubility decreases. So to summarise the findings from this experiment, you can see here when methanol has been added to water, it is completely soluble in the water. Okay, the methanol is completely miscible when we added it to water. And we had the exact same finding with ethanol as well. Okay, the ethanol with 2 carbon atoms was completely soluble in the water. When we then got to propan-1-ol, you can start to see this cloudy layer as the liquids become less soluble in each other. Okay, there's definitely a decrease in solubility in the propan-1-ol compared to the ethanol and the methanol. And then when we look at butan-1-ol, we can see here that the butan-1-ol is completely insoluble in the water. It's sitting as a layer on top of the water. Okay. And then finally with pentan-1-ol, the exact same. Pentan-1-ol is insoluble in water. It's sitting there as a layer on top of the water that we added it to. Okay, so as we go from methanol with 1 carbon atom up to pentan-1-ol with 5 carbon atoms, there is a decrease in solubility as that alcohol chain length increases. So in this experiment, we want to look and see if we can see a trend in the ease of evaporation of the alcohol family. So all I'm going to do is put a couple of drops of alcohols from methanol up to pentan-1-ol on this blue tissue paper, and we'll be able to observe how quickly they evaporate. So if I start with a couple of drops of methanol, and next to that I'll put a couple of drops of ethanol, and next to that I'll have a couple of drops of propan-1-ol, next to that a couple of drops of butan-1-ol, and then finally next to that a couple of drops of pentan-1-ol. So as you can see there, methanol, the smallest of the alcohols, has been the first to evaporate, and that's been followed by ethanol with 2 carbon atoms. And if we were to leave this experiment running, we would find that the propan-1-ol would be the next to evaporate, followed by the butan-1-ol, and finally followed by the pentan-1-ol. And we'd find that as carbon chain length in the alcohol family increases, that is, ease of evaporation decreases.
So as I said at the start of the presentation, to be successful you should now be able to describe and explain the trends in melting points and boiling points, the solubility and the ease of evaporation of the alcohol family as we go from methanol to ethanol to propan-1-ol, butan-1-ol, etc. So you should be able to link the size of the alcohol molecule to those physical properties.